Which of the following is the weakest base? So there are a couple different ways that we could approach this. And the one that works best for you would be the way I would advise you to look at this. So one of the things you could do is consider that the weakest base is the least reactive base. Another way to say that is that it is the most stable base. And so the trend that we have been using to evaluate the relative acidity of acids is actually a trend to say how stable is their conjugate base. And so this is the trend we've been looking at, is the Cardiot trend. So charge, atom, resonance, dipole induction, and orbital. And this is roughly the order that we're going to look at these for. And so we're looking at this now to look at the relative stability of the conjugate base, right? So a weaker base in terms of charge would be one that was neutral rather than one that is negatively charged. And so we can see that these are all anions, okay? So they all have a negative charge. Atom, so we can compare the atom that has that negative charge. So we can look at O, we can look at N, C, and again O. So we are looking at atoms that run across the same row of the periodic table. So we know carbon, nitrogen, oxygen, right? And our electronegativity increases going towards the oxygen. And what we've said when we were evaluating in terms of acidity, we said that acidity increases in that same row. So that's if your acidic hydrogen is attached to one of these atoms, right? So you're comparing as it's attached to a more electronegative atom, you have greater acidity. If we're looking at the conjugate base, we're really explaining why the acidity increases, and that's because a negative charge is going to be better accommodated on the more electronegative atoms. We could also say that base stability increases. And a more stable base is a weaker base. That means we're going to look at the two that contain oxygen. So we're going to say this is not a weak base, and neither is this carbanion. So now we got to move a little bit farther down the trend. So the next thing we see is resonance. So resonance is also something that can help to stabilize a negative charge. And so we can see in A that we have resonance, and the way that we can tell that is the presence of that pi bond next door, because that allows us to delocalize those electrons. So these two oxygen atoms actually share this negative charge. So that's that resonance. So A is the weakest base. Okay, so you can go through this trend in terms of the weakest base and talk about it in terms of base stability. You could also draw the conjugate acid of each of these and then compare, and you'd be using the exact same trends in terms of relative acidity. So you might recognize that if you were to draw the conjugate acid of A, conjugate acid, you would get the carboxylic acid. And if we're going to compare this, let's just compare it to D, because we know it's not B or C. So the conjugate acid of D is this alcohol. And so what you would have said previously is that this is the stronger acid. Right, so if you're able to identify acid strength and you're more comfortable talking about it in terms of acid strength, go ahead and do that, but recognize that the stronger the acid, it gives you the weaker conjugate base. And so that would also lead you to the right solution for this problem.